A great teacher always inspires learners. Good morning, good morning, good morning. Take a look on the different pictures shown on the slides. Can you still recognize what the pictures tell us about? Okay, very good. Wave, electrons, and particles. So, class, these are the things that we are going to learn today. So, are you ready to learn new things today? Okay, let's explore the world of science. I am very glad to be with you today and be a part of your adventure and exploring the wonder of science world. I am teacher Evelyn, joining with you today with the science world on the dual nature of electrons. But before we will begin, let me check first if you are ready. Do you have your pen and notebook and of course the learning module with you? Okay, very good. So let's get started. Our lesson for today is all about the dual nature of electrons. So for lesson 1, is an electron a particle or a wave? So for our learning objectives for today's lesson, first is describe a particle and a wave. Explain the concept of electron as particles and a wave. Okay, time to meet the structure of an atom. Do you know what is an atom? I know in your grade 7, you already discussed this topic about atom. But anyway, atoms are the basic units of matter and the defining structure of elements. So the term atom comes from the Greek word for indivisible because it was once thought that atoms were the smallest things in the universe and could not be divided. Okay? What are the building blocks of an atom? Okay, very good. You have the proton, electron, and the neutron. Now, take a look of the components of matter. What makes up matter? Okay, so the answer is here. Take a look on this illustration. Now, question. Is electron a particle or a wave? What is a particle? A particle is described as a minute portion of matter and is also referred to as the smallest known building blocks of the universe. This means that everything makes up matter and the universe is called particle. So scientists once thought the most fundamental building blocks of matter was a particle called atom. So now we all know that the atom is made up of many smaller subatomic particles. And every atom contains a central core that is what you call the nucleus. And this nucleus is made up of particles called the protons and the neutrons. Okay? Now, the electron is a subatomic of particle, right? So, this electron, whose electric charge is negative, one elementary charge. So electrons belong to the first generation of the lepton particle family and are generally thought to be elementary particles because they have no known components or substructure. So try to look at this 3D diagram illustrates the electron and the nucleus. So the electrons are the one moving in the orbit of the nucleus, the orbital shell of the nucleus. So that is where the electron can be found. Okay. So take a look on these pictures. This is illustrating the structure of an atom and what is the subatomic of an atom. So you have here the proton, so the neutron and the electrons, and where they can be found in an atom. Okay. Where does the idea of electron being a wave came from? So it is just like having two different worlds molded into one. A sound impossible, isn't it? So let us continue exploring by understanding what is a wave and if electrons manifest this wave-like behavior. Okay, now let us know what is a wave. So in physics, a wave is described as a disturbance that travels through space-time and medium, accompanied by transferring energy from one place to another. So a medium may be a substance or material that carries the wave. So class, remember that if there is no medium, then no one would carry the wave. So it needs a medium to carry the wave. Okay? So that material is a medium. So let's find out who are the medium or materials and carrying out the wave. Okay, so we have here the and this one and that one. So what are those? Okay, you have the water, the air, and the electric and magnetic field. Very good. Another example for a material that carries a wave. So it is being shown here in this illustration. When a slinky is stretched, the individual coils assume an equilibrium or rest position. So it is also very clear how it is being described, right? And for the second picture, when the first coil of the slinky is repeatedly vibrated back and forth, a disturbance is created which travels through a slinky from one end to the others. Okay? Okay, now let's find out how do waves move and interact. So we have the constructive interference and destructive interference. So what are their differences? Or how do they differ when in terms of their movement? Okay, sometimes when the waves come together just right, when crests meet crests and you get double waves, so this is what you call the constructive interference. But sometimes the wave cancel each other out and you get nothing at all. So this is an interaction known as the destructive interference. Okay? So we have here the diagram or the illustration of constructive interference and the destructive interference. So crest meet crest, then what it produces? Wave. So this is for constructive interference. And for the destructive interference, when waves cancel each other, then what happened? So none waves at all. No waves at all. Okay? So this is how the movement of waves, or this is how they wave interact. Okay. So this wave can also be described as an oscillating wave. So waves are oscillations, meaning they wiggle, they transport energy from one place to another. So waves don't really bounce off, but instead interfere with one another. Oh, thank you! The last, but never be the end. Anyway, class, uh, I hope you enjoyed and learned new things for today. But before that, I want you all to check your learning path and go over with the quizzes and the activities and submit that not later than Friday for me to check also your output. So thank you and God bless. And stay safe everyone. Then see you next meeting. Bye bye.